Hello algebra students, this is Mrs. Palmer and we are going to talk about factoring, and specifically in this presentation, factoring differences of two squares. So that is just one particular type of factoring and we are going to focus on that. What makes a difference of two squares? Well, this is a binomial. And a difference of two squares will always be a binomial because by definition it's two terms, and specifically the binomial will have a minus sign in between the two terms. So first a binomial, second a minus sign, and third the two terms will be perfect squares. Alright, so now what I have here is a model, a squared minus b squared. So let's just go through these requirements again. It is a binomial because you see two terms. There is a minus sign connecting the two terms, and both of the terms are perfect squares. Now just as a little reminder, a perfect square means that when you take a square root, you get a nice, neat term out that comes out from underneath the square root. So now for this model, going back to this, if we were going to factor that as a difference of two squares, that would factor in a very particular way. The square root of a squared is a. We've just demonstrated that here. And I would have my two a's, and they would go in the front part of both sets of my parentheses. The square root of b squared is a single b, and that would go in the back part of my two sets of parentheses. And very particularly to differences of two squares, one sign is a plus sign and one sign is a minus sign. Now no, it doesn't matter which one is plus and which one is minus as long as you have one of each. Now just to review from our multiplication skills, and let me change color so we can see it just a little bit better. If we were going to multiply these back out, just to show that this is in fact how it factors, oops, a times a would be a squared, a times minus b would be minus a times b, like this, positive b, positive a, plus ab, and plus b minus b would be minus b squared. So as you can see, these two middle terms cancel away, and we do in fact end up with what we started with. So this is how we would factor, and just a reminder, factor means breaking into parts a difference of two squares. So it's a very particular type of factoring problem. So now we're going to do a few examples. This is a basic example, x squared minus 4, but you still want to go through the process of checking that this meets all the requirements of being a difference of two squares. We have two terms, so we have a binomial. We won't do this every time, but just as we're starting, so check, yes, it's a binomial. There is a minus sign. Yep. And both terms are perfect squares. Sure. We know the square root of x squared, and we know the square root of 4. So now to factor this, another check mark, we would have our two sets of parentheses. The square root of x squared is x. The square root of 4 is 2. 1 plus, 1 minus. Little reminder, no particular order in that. And just to check that we factored correctly, this is our answer, this is our factoring. But if we want to check and see if we factored it correctly, we can always multiply that back out and make sure that we get x squared minus 4. Just another quick review, x times x is x squared, minus 2x, plus 2x, minus 4. This is what is special about differences of two squares. The two terms in the middle cancel, and you can see we do get x squared minus 4. So let's continue. Okay, so now I'm just going to verbally go through the process. Yes, I have a binomial. Yes, there is a subtraction sign or minus sign connecting them. And yes, they're both perfect squares. Now, 9a squared looks a little tough, so maybe I would want to make a note to myself. What is the square root of that? Well, the square root of 9 is 3, and the square root of a to the 4th would be a squared. So yes, it's a perfect square, and yes, I'm going to be able to factor it. So as I go to factor it, I get 3a squared and 3a squared. Always a good idea to just mentally check that if you multiplied these two terms together, you would get your first term. And I know the square root of 25 is 5 and 5. 1 plus, 1 minus, and there I have it. All right, again, always you can check with the multiplying. Okay, here's another one. Well, this is starting to look a little complicated, but still two terms. They are both perfect squares. I'll show you how it works. And there's a minus sign. So the square root of 100 is 10. Square root of x squared y squared would just be a single xy with each 10. The square root of 81 is 9. Now this can get a little weird. The square root of z to the 6th, it seems like you want to say, oh, that doesn't work. But remember, you add exponents. You don't multiply them. So 9z to the 3rd will do the trick. So a 9z to the 3rd in each spot, 1 plus, 1 minus. So maybe it's a good idea to check this one out a little bit. So multiply the first two. 10 times 10 is 100. X squared, y squared. Wow, this is going to get complicated, huh? But we'll still do it. Minus 90, xyz cubed. And then plus 90, xyz cubed. We knew that should happen because we're doing differences of two squares. And then finally minus 81, z to the 6th. Cancel the middle terms, and you can see that it works out. Okay, so now the square root of 1, is it a perfect square? You bet it is. The square root of 1 is just 1. So yes, this meets all the requirements. Square root of 144 is 12, forcing you to go back to your times tables to remember that. We just did one like this, so we know that that will split apart a cubed and a cubed, a 1 and a 1. And just to show you it doesn't matter what order you put the signs in, how about this time we do a minus and a plus? So, yep, there we have it. Oh, goodness. Well, this looks like it's a no-go from the beginning because 7 is not a perfect square. The square root of 7 is just going to be a long decimal. Now, we have some skills with this. We know it's going to be in between 2 and 3. Maybe closer to 3 than 2, but we don't know exactly what that is because it's an irrational number, meaning it's not a perfect square. But one thing that we can do here is look for a GCF, greatest common factor, because maybe these two terms share something. And in this case, you can see that they do share something. They both would be divisible by 7. And a. They both have at least one a. So maybe if I take that out front, what would happen? Well, if I took 7 and a away from this first term, I'd still have 4 a's left over. And if I took 7 and a, which is really like dividing by 7a, guys, so just let's keep that straight, I would get a 4, and the a would reduce, but I'd have a b squared. So now that I've taken out that GCF, I can see that what I'm left with in the parentheses is a difference of two squares. So I can continue this process, making sure not to forget my 7a that's out front because it's important, it makes a difference. The square root of a to the 4th is a squared. And the square root of 4b squared is 2b in each spot. Okay, now if we want to check this one, you would want to first FOIL or multiply those two binomials together. You'd want to do that process first and then distribute the 7a in to check and see that your answer is correct. But this whole thing would be our answer. So you can see that factoring can give us some pretty long results, but that doesn't mean that they're wrong in any way. All right, so now quiz yourself. Here are 3 questions, and one of them, the last one, hint, hint, requires you to factor out a GCF. So take a look at them, maybe jot them down on a piece of paper, and give yourself a little quiz. I'm going to give you a minute to try them. Get going. Okay, so next up, I know that was fast, but here come our solutions. So you can see that you can easily factor 1 and 2 right away. They're both differences of 2 squares. But down here at the bottom, you first needed to take a 3 out, and then your result was a difference of 2 squares, which you can see that we continued to factor. So that's it for this recording. Just a little work on differences of 2 squares specifically. We will be doing more factoring and more factoring, so happy learning.